Hi, my name is Jebelvin, and this video is to describe my final project for GIS410 510. For my final project, I wanted to look at flooding, specifically in the Durham, North Carolina area. This is because my focus is on climate change and how an increase in significant weather events and an increase in significant precipitation can cause flooding in certain areas. So if we look at my questions, I kind of wanted to tackle this problem in three phases. So the first is, what are the areas in Durham that are at highest risk of flooding due to low elevation and proximity to water bodies? Second is, what are the areas in Durham that are at high risk of flooding due to slope and aspect of the surrounding areas sort of funneling precipitation towards that area? And then third, what are the areas in Durham that are at the highest risk of flooding due to a low soil infiltration rate? So to answer this first question, we can take a look at this data that I grabbed. I grabbed the North Carolina wetlands data from the U.S. Fish and Wildlife Services data website. I grabbed the Durham, North Carolina DEM raster model from the North Carolina State University website. And then I also grabbed the Durham County boundary, which you can see here in this green polygon from the City of Durham website. And so to determine the areas that are at the highest risk of flooding for this first question, we had to determine proximity to the water bodies first. So to do that, I decided to clip the wetlands polygon layer to the City of Durham, because this would drastically reduce the processing time for any future tools that I wanted to run. After I did this, I then buffered those wetlands to 150 feet, but I did the outside only buffer, so it didn't include the actual water body itself. And this can be seen from this wetlands buffer right here. So if we zoom in, you can see that these polygons don't actually include the water body that they were being buffered off of. So now that I found the areas that are within 150 feet of a water body in Durham, my next big problem was to determine the elevation from this raster model and then classify those areas as either high risk or low risk. So to do this, I reclassified the digital raster model into 7 separate classes, and then based on each one of those elevations, I determined whether I labeled that area as either extremely high risk, high risk, medium high risk, medium low risk, or extremely low risk of flooding. And this can be seen in my web map. So right here, we can see the results of answering the first question. So all of these polygons right here on the screen are areas that are within 150 feet of a water body in Durham. And then the color is their classification as to whether or not they're very either high risk or low risk in terms of flooding. So as for expected results for the future, my goal is to use that digital elevation model to determine the slope and aspect of a lot of these areas that are within 150 feet of Durham, and then determine if there are specific areas that are going to be the precipitation is going to be funneled towards those areas and have a higher risk of flooding. And then, in addition, determine which of those areas have soil that offers a lower infiltration rate, which will increase the risk of flooding as well. And hopefully the combination of all these factors will produce an accurate map of areas in Durham that are at an increasingly high risk of flooding due to an increase in extreme precipitation weather events. Thank you.